So these last two, we've got two more to do. And again, what I'm kind of hoping to have us explore is if we understand the different ways that power is generated, we can kind of start to see different ways to get away from carbon-based sources of energy, whether that's for transportation or whether that's for electricity generation. The kind of interesting thing is actually the play between transportation and electricity generation as we begin to electrify our transportation fleet. We start to actually see the impact of those renewable or those carbon low or carbon neutral sources actually become a part of the transportation, which up to this point has basically just been oil, right? But we can basically see the replacement of oil as that source, and it's replaced with electricity and all of the downstream things. And again, I saw a comment today from a friend that was just saying, that was along the lines of how electrical vehicles are connected to dirty power sources. And it's true in a way, but it's not true in the sense that the power sources are easy to change, right? And so however the general power generation portfolio is changing, that determines kind of what the electricity is that's going into the car. We've actually seen kind of in big picture some very encouraging changes. Okay, so let's talk about solar and how solar works. And there's really two ways. The way that you're probably the most familiar with generating power via solar is something that we call solar photovoltaic. I'm not going to get too deep into the physics of how a solar panel, or what we call solar photovoltaic, I'm not going to get too deep into the weeds, kind of the physics behind how a solar panel works. But generally, when we're thinking about a solar panel that you might see around town or you might have for your camping equipment, or you know, the solar panels that pop into your mind when we think of this, that's what we call photovoltaic. And essentially, the big picture of the way that they work is they're kind of like an Oreo cookie, but in this case, the Oreo, the cookie part, they're slightly different materials, and the cream filling is essentially an electron barrier, something that electrons can't pass through. So the way that it works is solar energy from the sun, like photons come down, they hit us, right? We get a lot of energy from the sun, and when they hit this, this N, we call this an N-type semiconductor. Semiconductor meaning it kind of conducts electricity. That energy will actually dislodge electrons. And so there's actually a whole bunch of extra free electrons being sourced in this N layer, the top layer of a solar panel. And they don't have anywhere to go because they're being dislodged by the sun. The other portion of the solar panel, the P-type semiconductor, the back part of the panel, is made out of a material that is missing electrons. It has an electron deficiency, so it's something that's attractive if you're a free electron. And by connecting the two, we can actually create a current through a wire that goes from the top, the N layer, down to the P layer, and that discrepancy is actually how they generate electricity. We figured this out in the 1940s. It's just like crazy expensive to do back then, but you know, the science checked out, the paper worked, you know, you could kind of write out all the equations and the materials. I think we put them on the White House in the 70s. And really since then, solar technology has been kind of growing by leaps and bounds. And as that technology has been growing by leaps and bounds, the price for solar panels has plummeted. They become cheaper and cheaper and cheaper, and they're more and more and more efficient. The other thing to think about is that this P-type, generally over time, it loses capacity to absorb electrons. And so a solar panel might have, you know, kind of giving it the benefit of the doubt, might have a life of 25 years. But that means it generated power for 25 years, again, offsetting traditional carbon sources. Some of the other benefits of solar photovoltaic are that it's incredibly scalable, right? So you, like I said, you might have one for your camper. My wife and I, we have a small little, I think it's a 20-watt solar panel that we use to slowly charge the battery on our camper. But you can hook a bunch of these together. You can make a really large solar array, and we have some very large solar arrays in the world that collectively generate a significant amount of energy. Those are not evenly distributed, right? So there's also some parts of the world that get more solar radiation. You guys are very familiar with me drawing the Earth and kind of looking at how the sun hits different portions. So generally near the equator, kind of plus or minus in places that have fewer clouds, so desert areas. If we look at the desert Southwest, that's where some of these just massive solar installations have been put in. But you might put 15 or 20 of them on your house or on your business. There's lots of different ways to implement solar, and that's what makes it so great, is that it's incredibly scalable. And it can have a significant impact. It does have a significant impact on the energy that we use. Again, offsetting. So of all of the types of energy generation that we're talking about here, this is really the only one that doesn't spin the magnet, right? This is the outlier, right? This is using the properties of different semiconductors, some that are electron rich, some that are electron poor, and using that deficiency to drive an electrical current, right? So photovoltaic, a volt is essentially the force that's pushing those electrons. So photovoltaic is not the only way that we can create electricity directly from the sun's energy. But this next one is like pretty far out there, but also very traditional, and definitely we use it. So in this case, this is a tower, and the top of the tower is a little bit like a water tank. Again, I simplify, we're not going to get into the details, but it's actually filled with salt. But we're going to make that into salt magma, right? Molten salt. And this is what we call concentrated solar. Concentrated solar or solar heliostat. So you might have been familiar with that word, like the Greek god Helios, right? It's the god of the sun. A plant that's a heliotrope follows the sun, like a sunflower is heliotropic. Either way, what we do in this case is we actually have a series of parabolic mirrors, and this kind of works like killing ants with a magnifying glass. And essentially what happens is the sun hits these mirrors, and those mirrors are all set up on a computer to keep essentially the focus of their ant-killing laser beam on this tower. And so this array of mirrors is all concentrating sun on this tank, right? This kind of elevated tower in the center of our kind of concentrated solar heliostat array. The benefit is that these are just made out of glass, right? They're made out of a mirror. So they don't use, the same sorts of kind of raw resources that solar photovoltaic does. And in this case, you just have really, really, really hot salt. And so you can go back to being traditional. We can take some water, we can pipe that up through like a heat exchanger, and when that comes out, we're going to have a tank of really hot water. Now, this part's not going to surprise you. We can now take that hot water, create steam, recondense it and put it back into our cold water tank. And once we've made steam, at that point, a concentrated solar plant or a solar heliostat plant works the same as everything else, right? It's spinning the magnet. And we've got a couple of these, right? We've got a couple of these in the southwestern portion of the United States. Again, they produce large amounts of electricity. There's a couple of famous ones there's a pretty famous one in Spain, a couple in the Middle East. So this is a great way to create power. One of the problems with solar photovoltaic, is that it produces the most energy during the middle of the day and not energy at night, which is not when we need it. This, because you're heating water, will generate power for about 12 hours. So a concentrated solar plant can actually provide baseline day-to-day power, although that does change over the course of the year as the amount of energy changes. But it's pretty cool, right? And again, thinking about ways that we can generate electricity without burning fossil fuels. This is a cool example, but not the cheapest, right? So putting in this type of system is going to be a significant financial investment, whereas putting in, an array of solar panels, the panels themselves are expensive, but the infrastructure is much less expensive.